Hello, hi everyone, and warm welcome back to the Math Simplified by HM channel. We are in the process of studying the fascinating world of triangles. Before we start, make sure to subscribe the Math Simplified by HM channel and click the bell icon. Please keep a notebook handy and pause as needed to make your own notes. Let us dive in. Today, we are going to explore how we prove that two triangles are mathematically similar. Normally, for two triangles to be similar, two major conditions must be met. Their corresponding sides are in the same proportion and their corresponding angles are congruent. Thus, for similarity of two triangles, the necessary conditions are that their corresponding sides are in the same proportion and their corresponding angles are congruent. This is the basic definition of similarity of two triangles. Always remember this. However, when three specific conditions are fulfilled, the remaining conditions are automatically fulfilled. This means for similarity of two triangles, only three specific conditions are sufficient. Similarity can be confirmed by testing just these three conditions. Now we see the AAA test for similarity of triangles. Let us read the theorem statement and understand it. For a given correspondence of a vertices when corresponding angles of two triangles are congruent, then the two triangles are similar. Let us break down exactly and why this works. To prove this, let us set up our problem in mathematical form. Given in triangle ABC and in triangle PQR, angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. In figure, angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. Now we have to prove that triangle ABC is similar to triangle PQR. And as per our definition, there are the two conditions. That first condition is their corresponding angles are congruent and their respective sides ratios are strictly equal. So we have to prove that AB upon PQ is equal to BC upon QR is equal to AC upon PR. To get started, we need to do little geometric construction. Let us assume that triangle ABC is bigger than triangle PQR. So we can make a point M on side AB and point M on side AC such that AM is equal to PQ and AN is equal to PR. Draw line segment MN. Now let us look at the new similar triangle we just created inside the big one, triangle AMN. Now this triangle AMN and this triangle PQR, we will see their relevance. In triangle AMN and in triangle PQR, side AM is equal to side PQ by construction. Angle A is congruent to angle P given in theorem statement. Side AN is equal to side PR by our construction. Therefore, triangle AMN and triangle PQR are congruent to each other by SAS test. Now, as these two triangles are congruent to each other, their angles must match. So angle AMN is equal to angle PQR. But in theorem statement, we have given that angle PQR is equal to angle B. Now see here, MN and BC are two lines and AB is the transversal intersecting these two lines. Now, since corresponding angles are equal, it proves that our constructed segment MN is parallel to side BC perfectly. Now, we have in triangle ABC, since MN is parallel to BC, just we have proved it. Using the basic proportionality theorem, we get AM upon MB is equal to AN upon NC. To get full length of the sides in our equation, we will use two quick algebraic steps. First step, invertendo, that means flip the equation. MB upon AM is equal to NC upon AN. Then we add the numerator and denominator using componendo to get MB plus AM upon AM is equal to NC plus AN upon AN. This can be also achieved by adding plus 1 both sides and then making denominators equals. We get MB plus AM upon AM is equal to NC plus AN upon AN. Now MB and AM are the parts of the side AB and NC and AN are also parts of the side AC. So adding we get AB upon AM is equal to AC upon AM. Now we come to the final conclusion. By our construction, we have AM is equal to PQ and N is equal to PR. So substitute AM is equal to PQ and N is equal to PR in our derived equation and we get AB upon PQ is equal to AC upon PR. So we have shown that here corresponding two sides pair are proportional. Similarly, by drawing a line parallel to AB, it can be shown that AC upon PR is equal to BC upon QR. Now we have AB upon PQ is equal to AC upon PR is equal to BC upon QR. Therefore, all three sides are proportional. Therefore, we have successfully proven that all the three corresponding sides are strictly proportional. That is, AB upon PQ is equal to BC upon QR is equal to AC upon PR. Because the angles are congruent and the sides are proportional, triangle ABC is similar to triangle PQR. Hence, we have proved our theorem. Thanks for watching and keep up with geometry practice. Before you go, please share this with your colleagues, drop a like and hit that bell icon. If you haven't already, make sure to subscribe so you don't miss our upcoming videos. Have a great day.